Hi, my name is Shubbhi Taneja, and I'm an assistant teaching professor here in the Department of Computer Science. I joined WPI in fall 2021, and ever since I've had the opportunity to mentor several undergraduate research projects, as well as work with some of my colleagues on collaborative research. Over an academic year, I teach a variety of courses. Most of them fall in the area of systems as well as a programming language course. So more specifically, I teach computer networks, operating systems, database systems, systems and networking programming. That's a graduate course, as well as a programming course using object-oriented programming principles for non-majors. So as far as my teaching style goes, it's very interactive, and it begins with learning students' names. I engage with them by addressing them with their names. I use classroom discussions, sometimes in the groups of two, and then when we have smaller group discussions, that eventually leads to a whole classroom level discussion. And my style is very student driven, meaning I collect a lot of student feedback and adjust the course to meet their needs. And finally, as far as the assessment in my course goes, of course, I love project-based learning. I do have projects in my class, and then I have frequent assessments in terms of quizzes versus a big midterm and a final. So I do frequent quizzes on a weekly basis to do the assessments in my courses. So that's my teaching style. Now let's talk about my research. So I conduct research in two primary areas. One being my core research, which falls in the area of high performance computing, and the second is in the area of computing education research. So let's talk about the HPC research. Ever since I've joined WPI, I've had the pleasure of supervising 3 HPC projects. In those projects, primarily, we've tried to find the performance bottlenecks in these applications that exist, and try to address those and reveal our findings through the MQP project reports as well as some conference papers. So the 3 type of applications that we've focused on in the past were machine learning applications, HPC benchmarks, and more recently we're looking at scientific workflows. So in different kind of applications, our goal is to be able to improve the energy efficiency of those and at the same time try to improve the performance of these applications. So I have my mentors that supervise these projects at Lawrence Livermore National Lab as well as Pacific Northwest National Lab. So our students here collaborate directly with these staff scientists at these 2 labs and work on high quality research projects for their MQPs. Lastly, my other direction of research is in the area of computing education. So very recently, I've gotten a grant that helps me develop activities where we can introduce the idea of parallel computing. So the concept, the programming that you do in your introductory classes primarily runs on a single CPU core. But today, the world is parallel. So even on your computer that you're watching this video on, or even on your phones, you probably have more than just one CPU core. So the idea is to be able to introduce the concept of parallelism and distributed computing without necessarily introducing a whole new class for students to take. So more recently, one of my students is helping me design an activity that we want to use in classes that teach algorithms, and through one of those activities we're going to try to teach you how to rewrite an algorithm that you may have written already, but now through a lens of parallelism. So without disrupting your existing curriculums, we're going to try to propose multiple such activities over the coming years so that it's easy for us to intervene the existing curriculums and teach students these super important and timely concepts. And lastly, my other research project in the computer education research has been to find data sets. So one of the goals of this project is to help faculty and researchers find the data sets that are good quality and can be used to either improve their own teaching or give students a taste of what real world projects would be like that use actual data. So this research falls under open education, open computer science education, or open data sets used in computer science education. So if any of these three projects interest you, feel free to reach out and I'll be happy to discuss more. And lastly, I want to say, if you're interested in learning the cutting edge CS topics, tools, techniques, WPI is the place for you. Good luck and thank you for listening.